the polysaf architecture is composed of each of these processing elements in identically sized sockets. So they have identical number of resources to be used. And this type of feature allows it such that you can optimize your design for one of these processing elements and be able to use that same design in any of the other processing elements, reducing time of needing to get the time optimizations to work for a particular socket. So the ability of the polysaf that we have is that these processing elements can communicate with their left and right neighbor and also with the controller. And so all that configuration is handled by these switch boxes. And so the switch boxes, what it's handling is there's a 4-bit tag line and a 32-bit data line. And really, for most things that we've implemented, the tag line is just a 1 that there's data coming in and a 0 if not. But you have 4 bits if there was ever any further special features that a user wanted to do for handling different tag values. And currently, the processing elements we have is 5, because we put it on a Vertex 4 SX35, and we're just demo exactly the setup we have. The setup that we're doing, just brief before we go into the demo, is that each of these processing elements is just a simple adder where it takes the value coming in from the right, adds 11 to it, and then it passes it to its neighbor. And so we're going to actually take a value coming in from the controller. We're first going to write values 100, 200, 300, 400, 500 to memory, and then pass it from the processing element here on the further right and pass it to the neighbor on the left, left, left. And then the last one is just going to pass it out. All right, so let me get that demo up. So here we have the architecture setup of polysaf on a SX35 chip. And as you can see here, we have 5 sockets, socket 0, 1, 2, 3, and 4. And we have the static region where the controller resides, the microblaze, any of the other configurations that are needed for interfacing with it. So let me open up the EDK for you. So here in the EDK, the user will program their software, so they'll initialize the switch boxes. And here we're going to configure the switch boxes. Now, the configuration consists of 3 characters. The leftmost considers what's coming into the left input of the socket. The middle one consists of what are they sending up to the controller, what value, and the right one consists of what's coming in on the right side. So the left means the left side, I want the input coming in from my left neighbor. This middle one, because it's set to R, says I want to send the output from my right neighbor up to the controller. And this U says on my right side I want input coming in from the controller. So what we're going to do is we're going to take here on processing element 4 the data coming in from the controller, take it in, pass it back out to the left neighbor, and then the processing element number 3 is going to take it from the right neighbor, which would be processing element number 4, and process it and send it back out on its left side. Same thing for number 2. And then number 1 here is actually going to cut it short and actually just pass out the value from its right neighbor. So we're initially only going to be using 4 of them, and we'll later extend it up to using all 5 of the sockets. So here we're selecting, okay, I want data to come in to the switch box number 4, and then I want to check the value coming out from switch box number 1. So we're just setting parameters for the controller. So these are the constants. Actually down here is where we'll set which in and out boxes down here. So here we're writing values from the controller into the inbox we specified, which was number 4, and then here we're going to read out the values. So initially we're going to write values 100, 200, 300, 400, 500, read it back out, make sure they're okay, and then we'll send to write for addresses 0, 1, 3, and 4, and then read it back out for each of those and see what happens. So give me 1 second, I'll get the value out. Alright, so here we go with, let's get this to download to the board for our first example. And while it's downloading, let's clear. This is clear and ready to go. And so what we'll see is it write out the first 5 values to the memory. As you can see here, we're writing 100, 200, 300, 400, 500. We're just confirming that we could read those back out from the locations. And then, this is after it's been passed through the different processing elements. So we see here that 33 was added to it because it passed through 3 of them. And the fourth one, once again, only just passes it back up to the controller. Just for simplicity, we had the fourth one, processing element, act like it was pushing it back up, or that it is. But in the real programming, you can just have one of the other processing elements that did a previous computation just pass it back up to the controller. So now let's say if, for instance, you want to use all of the processing elements. So let's go up to the code, and now we are going to have it come out of the leftmost box, box 0, and let's change the configuration in the software. So now the first one is just going to act like the second and third one and just passing it to the leftmost neighbor. Alright, so there that goes, and now let's download this to the board. And so now, because it's going through 4 of them, with the 5th one passing it up, we will see that we'll have added 11 4 times. Alright. And while we're waiting, here we go. There we go. So now we see the same thing, 100, 200, 300, 400, 500. Same thing read back, and now we see that there's been an extra 11 added to it. So now it's 144, 244, 444, and 544. And so basically that's the basic demo of the PolySAF. More complicated algorithms can be done for it, and it's up to the user to implement for each of them. And just let me show you now the actual implementation of the static region on the board with each of the processing elements available to be implemented. Okay, so here we see the static logic that was shown in the previous, before we did the demo. And it has taken up all this part of the SX35 board, and now we see that each of the processing elements is available to be implemented with whatever logic. And so that's part of the architecture we have set up, where you can optimize for this single area, and then we have ARC that will go in. The ARC our complementary tool to be able to go and implement the design from this area to a different processing element. Sorry about that delay. And so that's it for the PolySAF. Thanks for your time.